Yeah, how you doing tonight?
Good, how are you?
Good. All right. Gosh, when I first looked at this, I looked at these first four pictures, and I had it minimized so that I couldn't see the dots. And
Oh,
I was desperately trying to figure out what the heck are they talking about? How do any of these things match up with nothing up here?
I
And then
found you.
I blew it up a little bit and I saw the dots. So now I know what they're talking about. Do you want to start with 35 through 38?
Yeah, sure.
Okay. First of all, if we look at the four graphs, there's only one graph that does not approach the horizontal asymptote y equals 0, right? That's B. It approaches a horizontal asymptote of y equal 8. Which of those four functions, as n goes to infinity, will approach 8?
35?
Now, 35, the denominator blows up, which means the whole thing's going to approach 0. 30,
Oh,
let's look at 38 for a second. 38 is an interesting function in that it's an exponential divided by factorial. Well, one thing you learn, you may not have learned it yet, but one thing you learn is that factorial growth always outstrips exponential growth. Always. In other words, as n goes to infinity, that thing's got to go to 0.
uh,
Okay? What if I gave you the following? What if I said y equals 8x divided by x minus 1? As x goes to infinity, what happens to y?
it gets,
Goes to 8. In other words,
uh,
because the power of that is the same as the power of that, the horizontal asymptote is the ratio of the coefficients. And that's what 36 is. Notice the ratio of the coefficients in 36 is 8 over 1. So that's the horizontal asymptote. So
oh,
36 goes with B because only B approaches 8. Okay? Now, the rest look kind of similar, although if we look at 38 and we start evaluating 38, well, what's 38 when n is 1?
uh, would it just be 4?
Yeah. Now, what is it when n is 2?
4/3.
No, it's going to be 4 squared all over 2 factorial. That's 16 divided by 2. It's going to be 8. So we got a sub 1 equals 4. A sub 2 equals 8. What's a sub 3 equal?
Um,
What's 4 cubed?
I'm thinking that's 64.
Okay, over 3 factorial, so that's 64 over 6. So that's about 10 and 2/3. Okay?
Okay.
Notice that as n goes from 1 to 3, we're rising. Well, there's only one curve that does that, A. And what happens with A is we reach this point right here, and then it starts dropping. So let's check some bigger n's to make sure that it drops. What is a sub 5? Well, that would be 4 to the 5th, but now it's divided by 5 factorial. How about a sub 10? Well, that's 4 to the 10th, but is now divided by 10 factorial. what's happening as n gets bigger is this thing turns around and starts approaching 0 again. We know that as n gets infinitely large, the factorial growth outpaces the exponential growth, so the denominator at some point in time gets bigger than the numerator. And a sub n starts coming down. So the only graph that fits for 38 is A.
Okay.
Okay? I don't want to spend too much time on this because we could take up the whole half hour with these first 4 problems. Now, that leaves C and D, and we can certainly see that with 35, as n gets bigger, it's going to 0, right?
Yeah.
Well, where does it start out? When n is 1, what is a sub 1?
8.
Okay, well, they both kind of look like they start close to 8. If here, n sub 1, if I plug in 1 for n, I've got 4. So in 37, for 37, a sub 1 equals, it's 4 times 1/2 to the 0 power, which is 4, whereas 35, our other possibility, a sub 1 equals 8/2. They both start out at 4. And you'll notice that first dot is at 4 there, and the first dot is at 4 there. So we have to try a sub 2. So in 37, what's a sub 2 equal to?
Let's see. That would just be 2.
Yeah. Whereas 35, a sub 2 equals 8/3. More than 2. Almost 3. So the graph that has to go with 35 is the one that has the second biggest point. That's C. Notice that when n is 2, C is about 2 2/3. Whereas in D, when n is 2, a sub 2 is 2. So this one, D definitely goes with 37, and C goes with 35. And the only way to really distinguish them is to plug in some values for n and see which one matches their points. Okay?
Okay.
All right, let's get on. The rest of these are more important. So what's the general formula? The most important way to start all math problems is with the general formula. For an arithmetic sequence, what is the explicit general formula?
I don't know. I was really confused by that, actually.
Memorize these, for sure. Now, you haven't gotten to geometric sequences yet, have you?
No. Yeah, we have, actually.
Okay, well, so far, we're just looking at arithmetic here. Oh, yeah. Interesting. Interesting. Okay, so if this is the general formula for an arithmetic sequence, there's other kinds of sequences. It's not just arithmetic and geometric. There are other ones. But this number 39 is definitely arithmetic because the distance between every term is the same. It's 3 plus 3. Okay, so what would the apparent nth term be? Well, I can see the first term is 1. This is still n minus 1, and the common difference is 3, right?
Yeah.
So now if I multiply that out, I get 1 plus 3n minus 3. Simplify it, I get 3n minus 2. There's your answer. In other words, as long as you start with the general formula, then you can just plug in everything you see. You can see that the first term is 1. You can see that the common difference is 3. Once we plug in both of those, that's all we need to get our answer.
Okay. So A1 is just the first term.
The first term. N,
and then
the whatever n is, if you're talking the nth term, it could be 25, it could be 3, it could be 4, it could be any number, as long as it's a whole number. And D is the common difference.
Okay, wait, I get those two, but could you explain N again, sorry?
N is whatever n is. In other words, let me go back a moment. What do we come up with? A sub n equals 3n minus 2, right?
Yeah, how did you find for N?
All right, let's go back. First of all, I start with 1. That's the first term.
Yeah.
Plus n minus 1 times the common difference, which I can see is 3.
Yeah.
Now multiply everything together. You get 1, distribute this 3, I get 3n minus 3.
That makes sense. Yeah, that makes more sense, actually.
Now
Thanks.
simplify to get this. Now, when you say what is n, well, if I want to know the fourth term of this sequence, a sub 4 would be 3 times 4 minus 2. Well, is it 10? If I look at my sequence, yes, the fourth term is 10. Okay, what if they said, what is the 111th term? What is a sub 111th? In other words, if there were 111 terms listed here, it would be 3 times 111 minus 2.
So it would be 31.
31. That would be the 111th term of that sequence. Okay, let's look at 40. Okay, start with the general formula. Oops, hold on. And plug in everything you know. What's a sub 1?
Which question are we doing here?
40.
40. So the first term is 3. And then your average is 4. So D is 4.
Now,
So then
multiply that out.
so you get 4n minus 4.
Oh, excuse me. Yeah, sorry.
You're good.
Well, you get 4n minus 4, which converts to 4n minus 1 when you combine the 3 and the minus 4.
Uh-huh.
Okay, so that's the nth term for that series. And if you want to test it, it's not a bad idea. If your life depended on this, I would at least test it. I can see the sequence, so the fifth term should be 19. Let's try it. A sub 5, is that equal to 19? Yes.
Yeah.
We got the right sequence.
Sweet.
Okay, now the next one. Wow. Well, this one is not arithmetic or geometric. Geometric is where every term is a certain ratio of the term before it. Like a geometric sequence would be 2, 4, 8, 16. Every term is twice as big as the term before it. That's what makes a geometric sequence. And they have a different a sub n. Their a sub n is the first term times the common ratio raised to the n minus 1 power. In other words, if I wanted the third term, which I can see is 8, so a sub 3 would be equal to the first term. The common ratio is 2. N is 3, so it's 2 squared. Perfect. So I've got the right general format. Once you find the right general equation for either your arithmetic or your geometric sequence, the rest becomes kind of easy. Okay? Now, this sequence that we're looking at here is neither arithmetic nor geometric. Notice what it is, though. I got a common difference between those two terms of 3, between those two terms of 5, between those two terms of 7, between those two terms of 9. Well, that looks a little like an arithmetic sequence with a common difference of 2. But I'm not sure I know how to put that into an nth term expression. Let's see if we can figure it out. Oh, man. Well, they don't make these easy. Well, let's see. A sub n must be, well, let's try a sub 1 plus, the common difference keeps getting bigger. So would it be maybe d plus 2 times n minus 1? That work? Let's see, the common difference is 3. So a sub 2 would be 0 plus 3 plus 2, 5 times 1. No, doesn't work. How did they teach you to do these? I'm not sure I know how to do them when they're not arithmetic sequences.
I'm not very sure how to do this either, to be honest.
I'm sure that it shows you in your chapter 8, but I don't have your book, so I can't even look to see an example of how you do one that is not either an arithmetic or a geometric. I'm kind of getting a clue, though. Let's look at 43 for a moment. Notice what 43 is going to be. It's going to be, the first term is going to be n plus 1 over n plus 2. First term would give you 2/3. Second term would give you 3/4. Third term would give you 4/5. That's the answer for number 42. Now, how do we do 41 or, I'm sorry, this is the answer for 43. Can you see why it is?
Yeah.
43 is actually pretty easy to do because the numerators go 2, 3, 4, 5, 6, and the denominators go 3, 4, 5, 6, 7. So it's easy enough to figure out that 43 has to be this. The numerator has to be 1 less than the denominator, and the first term has to be 2. So it has to start like this. Now, let's see if we can figure out some of these other ones. We've only got 7 minutes, so we might as well just focus our efforts on these. Let's look at 42 for a moment. I'm not sure I know how to do 41. I think if I fiddled with it enough, I could figure it out. But I think 42 is going to be a little easier to figure out.
Would it just be 1 over n squared?
Yes. In other words, this is 1. This is 1 over 2 squared. This is 1 over 3 squared. This is 1 over 4 squared. This is 1 over 1 squared. So it's 1 over n squared. Perfect. That's what a sub n is equal to, 1 over n squared. All right, I think after figuring those two out, we can probably figure out 41. 41, the sequence 0, 3, 8, 15, 24, we know is going to increase by 3, and then by 5, and then by 7. How about something like 2n plus 1? No, that won't quite do it. First, how about 2? Let's see. Second term would be the first term would be 3, and then 5. These are a little bit of trial and error. You kind of have to play around with a sequence that you think works. In other words, by trial and error, I figured out 42 and 43 and 44. 41, what's going to give us that sequence? First term has to be 0. Well, that means what? It means that the top probably is n minus 1 over, in other words, when n is 1, the numerator is 0, so we're going to get 0 regardless of what the denominator is. And if I make the bottom n plus 2, that's not going to, I think I got what it is. 2n minus 1. Now, when n is 1, we've got 0. When n is 2, we've got 1/3. Got these in reverse almost. I'm close. 2n minus 1 over n would give you a correct second term, I believe. No, it wouldn't. That would give you 3 over 2. So let's see. When n is 3, that's going to be 5. How about n squared? It's n squared minus 1. That's what it is.
Oh, that's a lot simpler.
That's the sequence, in fact. That's the whole thing. When n is 1, I got 0. When n is 2, I got 3. When n is 3, I got 8. When n is 4, I got 15. When n is 5, I got 24. Notice these aren't that easy to come up with. You kind of have to screw around a little bit. You kind of have to do a little bit of trial and error. So a sub n for this one is definitely that. All right, let's look at 45 because it illustrates just in the 3 minutes we have left here. 45 is an alternating series, okay? Notice that this term is positive, then negative, and then positive, and then negative. So it looks a little bit like this, right? Well, what would that be? That would be 1 over n squared, but it alternates. So I'm going to multiply it by that. Whenever you have alternating, you end up with one of those in there.
Okay.
Now, let's see if that works. When n is 1, the first term is minus 1, so that means this has to be like that. The first term is actually 1/2. Well, let's see. How do we get a 1/2? When n is 1, No, that would give us 1 as the first term. 1/2. When n is 2, you get -1/2. And then when n is 3, you get +1/4. So we're close. Just got to figure out how to... The alternating part comes always from this part here. Notice that as n counts up, this -1 becomes negative, and then positive, and then negative, and then positive, and then negative, and then positive. So the only thing we have to do is figure out how to get a first term of 1/2. Hold on, I'm thinking. Well, okay, how about this? 1 over n plus 1 squared times -1 to the n minus 1. There you go. I think that gives you the sequence. When n is 1, anything to the 0th power is 1. And the bottom wouldn't be 1/2. Let's take away the squared. Now we get 1/2 as a first term, but we don't give -1/4 as a second term. It's got to be this. I think. When n is 1, no, we don't get 1/2. I'm close. Unfortunately, I'm going to have to run, Jake, because I have a 6 o'clock, so I can't finish this. But hopefully you get the idea. And this part right here is very important. If your first term is positive, then it's -1 to the n minus 1. If your first term is negative, it's -1 to the n. So whenever you have an alternating series, you're going to have either this or this, depending on whether your first term is positive or negative. Still have to figure out the rest of it, and I didn't do that here, but I'm close. It's some variation of 1 over n squared. It is. In other words, this works perfect if I start at 2. I get that, and without the -1. In other words, this sequence right here that that gives you the second term beautifully. And it gives you the third term beautifully. The only term it doesn't give you is the first term, 1/2. What do I have to do to make that 1/2? I'm not sure. Anyway, I don't have any more time to spend on it, so I'm going to have to run. But maybe you can play around with that a little bit and figure out how to produce that sequence. The tough part is this part here, the -1 to the n minus 1. That is always going to be in any alternating series that begins with a positive term. This is going to be in any alternating series that begins with a negative term.
Okay.
Okay? Jake, I will talk to you next time.
All right, sounds good.
All right.
Have a good day.
You too. Bye-bye.